Hi. In this video, we are going to experiment with the debugging capabilities of Radari. As you know, debugging comes handy when you don't just want to look at the static assembly code, but you also want to know what happens if you do a specific action in a program, or what is the value of a specific variable at some point of the execution. So what we did so far was static analysis, and what we are going to do now is dynamic analysis. Since one usually does not have the source code when doing reversing, we will debug the program in an assembly level. Alright, this was already too much talking, so let's get to it. So in the previous section we could log in, but it didn't help us in our mission. So let's just start Radari again and look for something interesting. But to do debugging, I will use the -d operator and server.exe. At this point, the binary is loaded, but it's not executing yet. We will have to start it manually. So let's do the analysis. I will first list the function again. That's always a good point to start. So if you look through the functions in the binary, there is this function which is called secret. I mean, if you're doing any kind of security assessment, if there's a function called secret, then it's obvious that you want to know what it does. I mean, it's called secret. So let's try to find out what this secret function does. So I will use the cross references as we did earlier, if you remember the axt. So I will do axt, and we want to know where the sim.secret function is called from. And it says that it's called from the check username function at this address, and this is the instruction. All right, so we know that the check username function is going to call this secret. So let's go ahead and put a breakpoint at the beginning of the check username function. So everything under debugging is surprisingly under the letter D. So these are all the debug commands, and there are a few commands which we are going to use regularly. There's db for breakpoints, and there is dc to continue the execution. It doesn't say here, but we also use dc to actually start the execution. And there is do, which is open process. We are going to use that for restarting the process. So whenever something goes wrong and you want to kill the current process and start over, then we use do. All right, so let's put that breakpoint. So db for breakpoint, and sim.check username. All right, so this put a breakpoint at the check username function. If you get the help for db, it will tell you to list the breakpoint. You can just do db. And here is the one breakpoint which we created for the check username function. All right, so at this point, we can start the execution of the program, which we do with dc. And now the program is running and waiting for input. So I will open another tab and log in. So I will do nc localhost 14884, and we got the login, and we'll just say ASDF, and then nothing happens. And the reason for that, because we hit our breakpoint. And as you could see, our location in the binary is immediately changed to the breakpoint location. So now we can start looking at the binary, how it handles this username input. And you could do the whole thing from this normal command prompt of Radari, but what we are going to use is the visual mode, which can be started with capital V. Visual mode is just a different representation provided by Radari. Here in the top, you could see how is the actual screen which we are seeing is generated. And there are different views. And between the views, you can change with the letter P for Peter. That's already something more useful. And this is actually what I like, because here you see the assembly code. This is where we stand right now. The instruction pointer gonna tell us always where we are standing in the code. And on the top, you see all the other registers. So that's why I like it, because you can follow the registers. Two very important commands in visual mode. One is the question mark, which you can just type like this, question mark, and then it gives you the help for the visual mode. It's going to tell us things like to step in and step over is S and capital S, and generally how to navigate in visual mode. And of course, Q will get us out from the visual mode. So whenever you type something and you get to some weird place, you just need to push Q as many times as you need to get back to this prompt. But I need the visual mode now, so I go back and get here. So first let's try to understand what's happening here. So we are standing at the beginning of the check username function here, and if we go down a little bit, there's the compare username and etc, etc, and here at the end you would see that there is the call sim secret. So this is where we call the secret function, and if you look at here, there is a jump instruction here which will jump over this secret, and there is a compare instruction here. So there is some kind of condition which decides whether this function is going to be called or not. So we're going to find out what's this condition. So what we're going to do is just step over all instruction calls until that point and then see what's happening there. So the step over, that was capital S. Oh, by the way, you see this shows that we have a breakpoint here, just for your information. So with capital S, we start executing the instructions. You could see on the top how the registers are changing. This is where we read our username. Here we print something. There's the compare username. All right, and we are getting close. So I slow down. All right, so what we see here is that we are comparing this argument 8h to 0. So we want to know what's that value. If we go back a little to the top, so these locals and args, these are just labels created by Radari, and it refers to either local variables saved on the stack or arguments saved on the stack as well. So it's either EBP minus some offset or EBP plus some offset. So basically this arg8 is EBP plus 8 hexa. So there's a value there, what we are using as in this comparison, and if it's not equal, so if it's not 0, then we are jumping over the secret function. So basically the secret function is only going to be executed if this argument is 0. So let's see what's that. In visual mode, we can still get a normal prompt without actually leaving the visual mode. You can do that with colon, and then you can execute your normal Radari commands. To find out what is EBP plus 8, I will just print that memory address, or 4 bytes at that memory address. EBP plus 0x8. And it's the number 4. With px, we are just printing the hexadecimal values of this memory address. And with 4, I'm saying that I want to print 4 bytes starting at this address. And there, the first one is number 4. Okay, so we know that it's 4, but that's still not so much of a help. What we want to know, where is this number coming from? If there is a way to influence it or not. So I will go back to visual mode. So I will start to look around. So we're looking for this arg8 to see, how it's used. let's see. And here you could see that argate is used as an argument for the read function. And it's going to be the first argument because this is the last what we push onto the stack. So if we want to know how the read function works, I can just open another tab and then we can do manual read. It's the standard libc read function. And here you can see the arguments. So the first one looks like is the file descriptor, and the last one is the size. So if we look back here, we have this here, which rather tells us that it's 1023. So this is probably the size, and then what we push here from a local variable is the buffer, and the last one what we push, and which is the arg8, is the file descriptor. So at this point we need to stop and think about this a little. What this means. So our only input to this application is the username and password. Do you think there is a chance that the username and the password will somehow influence the file descriptor? Probably not, because usually file descriptors are generated one way or another. In C, usually when you open a file, you will get a file descriptor back, and then you can use this file descriptor later on in the program to refer to that file. So what this essentially means that whatever is the reason for this to compare the file descriptor to 0, we don't really have any impact on this. So my assumption is that in our case, we won't be able to give an input to the application which will make us get into this function. So this secret function is basically that code for us. So we can do two things right now. One is to analyze the function itself only statically, so without executing the function, or we can try to patch the application to make the application go into the function irrespectively of this comparison here. And that's exactly what we are going to do, but we are going to do it in the next section. So I will meet you there. Bye.